Amendment video on physics. So those not interested, run away. This gravity wave thing, just thought somebody said something, so amendum. Are they full of shit with the recent detection of gravity waves? Well, they're full of shit to say it as arrogantly, we did it. You know, that part is full of shit. Okay, the show looks pretty shitty. There's no way to get around that part. So anyway, the Miles Mathis guy did a commentary, so I'll link to that. And you know, he brought up some of the same questions you know, I sort of been asking. You know, how can you he doesn't say this, but this is sort of the gist of it. I mean, how can you build filters, you know, for aberrant noise when you don't know the full collection of aberrant noise? You know, there's an infinite number of there's a really big number of possible noises the Earth could make, or even the Sun, events that would be unlikely. You know, it's like a 20-year flood, right? You can live in a 20-year flood zone. So yeah, once every 20 years it floods. Right, but it only happens once on average over a 20-year period. So, you know, it's like ice ages or something. Stuff only happens, you know, at a certain wide intervals. But you can have a whole lot of those. So there could be a whole lot of sounds this machine has never heard. Fact. I mean, it's just a glorified seismograph. Let's sort of get real. I mean, this is all based on just this little squiggly line. That's the whole thing right there. And the point is that the squiggly line they got at both places, both locations, fits a model, a picture they drew ahead of time, presumably, hopefully. Yeah, hopefully it was ahead of time, of what something might look like. And they just match the picture, so to speak. But it does seem like they didn't have this particular picture in mind, so they did do some reconstruction, because, you know, they were open to the idea that it could be neutron star, this or that. No, it's too far away, or it's too weak, or it's too this, or it's too that. So it does seem like a lot of molding was put into this. But what would be nice to see is just these wave patterns. It would be nice to see what different things look like. You know, just for your own sake of understanding how this is so dramatically different. Like, you know, a 7 Richter scale earthquake or something, a tsunami, some other kind of event, just to get some idea of what things look like. You know, to this detector that's detecting this energy. Well, detecting this, we don't know what it is it's detecting, right? So that's the other part I want to go into. So anyway, the Miles Mathis article he was doing okay. You know, the first half of it, okay, I was like on board. Okay, yeah, there's a lot here to be skeptical about in terms of the conclusion drawn, because how can they possibly eliminate even chance? You know, they have a zillion of these waveforms every day, right? A zillion. This is a microsecond, right? This whole event is a microsecond. So there's so much of this in a single day. And, you know, it's just possible that you'll get a signal, like something makes a noise, and that signal will match what you have in your computer, like monkeys on the typewriter. It seems if you're going to have something that you're going to say, we might only detect one of these events a year, well, that might be the probability of coincidental match. And I don't know how they can possibly eliminate that as being a possibility. I mean, coincidental in the sense that there's some minor event that creates a aberration that both detectors detect as matching some bigger event. You know, some closer event that's louder than some distant event that's soft, kind of idea. So, I mean, there's just a lot to say. Gee, this is so... wow. You know, I mean, they have to get so many of their presumptions right for this to be right. And that's just a little bit bold. That's all. It's just a little bold to say, we have done it. Because as if this is what doing it is, I don't know. maybe you should have been trying to do something else, because this isn't quite what doing it should look like. I think doing it should look a little more decisive than this. But whatever, that's me. I'll get into those details. Anyway, so still going to try to get back to the Miles Mathis thing. Jeez, I keep getting distracted by my own train of thought. So anyway, if somebody had some input, because I thought look, the guy's smart, but I thought his argument was really stupid, because he started making this argument about, well, what they're seeing is an electron being accelerated in the mirror and blah, blah, blah. And you're like, well, how could they see that at both locations? I mean, come on, just, it is both locations, so come on, you can't. How is that possible? So if somebody has an explanation for something that maybe I'm not understanding about his critique, how could that critique possibly mean? I mean, that's one of the things you could eliminate by just saying, well, look, they've got pretty much the same signal in two locations. It can't really have something to do with both hitting electrons in mirrors at the same time. That seems really unlikely. But there's a lot about this to be, they should have, I understand they want to be, we did it, but just the fact that they detected this in a test run. Okay, yes, your test runs are just like their regular runs, but it was a test run, and it was only 3 minutes into the test run. I mean, these are things to make you a little bit, ooh, that's that's not quite, that's not really how you want it to happen, is it? Especially for your first, this seems a little bit of a preemie. I don't think you let it grow quite good. I don't think it's gonna, this isn't the kind of stuff you want to, just not hardy enough. So many things I can say. Well, I don't buy some of this crap they say happens anyway. But anyway, so if somebody has somebody smart enough to be able to read that Miles Mathis thing and then explain to me how what he's saying could make sense in the fact that they have two detectors. So I'm just saying his critique just, and again, he's another guy. It just seems like he's awful confident that he found the flaw they made, and I'm like, well, this, it seems like it's kind of got holes in it too. So anyway, so my take on this is this. I can't see this as anything but a destruction in a way of the whole theory of relativity and the bent space model. In a sense, they're going to have to come up with some sort of dark matter crap or some other kind of bullshit to make this sort of make sense in a way. So let's just understand the classic model is that these things, the idea is that matter tells space what to do and space tells matter what to do, but matter doesn't turn into space. Okay, so there's no gravity without something causing gravity. There's no evidence that there's gravity without mass causing the gravity. So the idea is that these things are spinning. The only conclusion I can draw from this data is that they start deteriorating. So that's what this signal represents, is they're spinning around each other. They have incredible speed. So let's just understand this is about moving. These things are moving half the speed of light, and they're doing it in a circumference of a few hundred miles. That's what the theory is here. Less than less than the distance really from one side of the Earth to the other, less than the diameter of the Earth. These things are spinning in that diameter, moving half the speed of light. That doesn't sound, and they weigh as much as 30 suns. I mean, this whole compressed matter thing, I don't even think they've even done that where they've demonstrated that this makes any sense. I mean, the matter, black holes would have to be incredibly cold. Your first logical conclusion is, all right, if I want to compress matter, like I want to make, let's say I had a lump of steel, and I wanted to make that lump of steel smaller, so small that it just took up the space of a period on a piece of paper. Right, so that's what they're doing. They're taking like a 1-inch lump of steel and compressing it to the size of a period. Now, obviously, you couldn't do that with any heat in there at all, right? So there can't be any impurities. There certainly can't be any heat. And you're molecularly doing something like carbon diamond thing, or I can't even compare it to anything because we don't know of anything that can do this, right? We don't know of any element that can compress to such ratio. that you could do such a compression with in some sort of solid state. Obviously, gases can, well, some gases. Even that's a good example in the sense it's hard to compress even gases. It's hard to compress anything. With all our King's Men and all our Humpty Dumpty technology, we can't do this compression thing. And so why do they think it is even possible to compress the mass? Okay, we're talking about the mass of the sun, which is, the sun is preposterously large, but that's the funny thing, is that its gravity on its surface is only 7 times the gravity on Earth, because it's not dense. But there's a ton of it, but it's big, really big. So they're taking all that, something 1,000,000 times the size of the Earth or something, it's really big, and compressing it into this little ball. Through what possible molecular technology is this possible? So it's right there. I have a first problem with everything they're talking about is only theoretically possible. It's not factually possible. There's no demonstration of this stuff. We've never captured any matter in this super condensed form. We've never seen matter in this super condensed form. So anyway, I just argued that this stuff would have to be incredibly cold, and it probably doesn't behave like normal matter, right? If it's that compressed, maybe it can't even have a velocity. Maybe it can't be moved in space, because it's not susceptible to the same kind of knick-knacky forces. I would certainly argue, just from my theory, that matter in that state might be impervious to movement because it can't do any of this exchanging thing with the environment. Impervious to having velocity, because that would cause there to have to be misshapen atoms. And how can you even have normal atoms? To do what they're saying, the atoms have to, like the electron has to be smushed right into the proton and neutron kind of thing. You have to take out all the space out of the atoms. And how do you do that and still have the spins necessary to keep things from going faster than the speed of light and all that kind of stuff? So, obviously from my theories, I'd have a real problem with this condensed matter thing making any sense, because I believe the energy is still in the matter. So anyway, so that's the first problem with this. But let's say that can happen. They're detecting something now. They're saying, okay, this happens once a year, twice a year in this hunk of the universe. So overall in the whole universe, I guess one happens every 10 days or something. How do they know any of this stuff? You'd say, well, it seems kind of surprising to me that, with this untested technology, pretty much, that they're detecting things that happen and this rarity in huge hunks of the universe. Something that, just doesn't seem, it's like catching the biggest fish on the first day or something. I just don't know if you're good enough fisherman on the first day to catch the biggest fish ever. Just doesn't sound quite right. So that doesn't appeal to me as, horribly logical. But, alright, so let's just get to the point here. So what's happening here? The only way they can be detecting this part is that as they're circling each other, they have to start ripping each other apart. You wouldn't have this detection here of the cycling. You wouldn't be able to detect it from 1 billion light years away or 500 million light years away if this wasn't already being made out of the mass of these two objects. So they're losing mass as they're condensing, or you wouldn't be able to see this. And then you have to just wonder, well, how much mass, what's the ratio of the mass loss? So if you go by how far apart these waves are, see, they get closer and closer together as they get to this end here. And that's sort of the energy level. So it's not so much the peakness that's energy, it's the narrowness that dictates energy by this theory, I think. I think that's how it works. So, they're losing mass. So you can kind of see that this doesn't seem, it almost seems, so I'm just saying this is a tiny amount of time. And you're just saying, well, does that really make sense to me that these two things are spinning and they do all of that stuff at this last moment? Like, they're not, well, first I would argue, how do black holes even get into relationship with each other? Like I said, a black hole is an incredibly dense thing, right? And most dense things are, the only way you have movement is you had to acquire it from stuff banging into you, stuff you absorbed in some way or another. Something had to push you, like a sun blowing up or something, which is the same thing as you absorbing that energy, the little bits. Are impacts, with things that have a velocity, and you kind of absorb a hunk of their velocity. But that's the only way things get velocity. They just don't have it magically. The matter sort of has to find it in the environment and get it. And these are incredibly dense things, and you're just saying, well, where did all that velocity come from that they even had a chance to encounter each other? Where did black hole A come from? Where did black hole B come from to merge in the first place? Well, then there's the whole problem of 3 solar masses. So it lost 3 solar masses in a millisecond. I mean, even if I was to say it lost 3 solar masses in 3 seconds, 3 solar masses released is just it's a preposterous amount of energy. You can't even describe how much. I mean, the whole universe burning all day. 3 solar masses might be more energy than the entire universe working all day. I mean, suns last billions of years. It's a tremendous amount of energy. So what is it? And so this is the problem with. All right. So anyway, so I mean, right there, I have a real problem with this theoretical projection that all this shit happens in this tiny amount of time, and that 3 solar masses are released in even just 3 seconds. Let's just say it happens in 3 seconds. 3 seconds, 3 solar masses is just let loose, and in a form that is theoretically what? Okay, this is like positive gravity, not negative gravity. Okay, so the regular thing with gravity is the mass causes the gravity. So if they're going to say 3 solar masses worth of gravity, this is an indication of gravity going out. It has to have little bits that are causing the gravity. So it'd be like a clump of something. All right, so it's a bunch of little tiny clumps of sun, okay, that get released to create this wave. That would be still negative gravity then, but then you're stuck with these clumps. And why don't we get the clumps, right? We're not receiving anything like matter or detectable radiation. It's not any kind of otherwise detectable radiation. You only can detect it because it's moving the Earth from 500 million light years away. Tremendous amount of energy. Come on, this is the sun probably can't. All that sunlight doesn't move the Earth that much. A lot of movement in a very tiny amount of time. A lot of movement. But nothing that's detectable as any form of radiation. So that's why they're saying it's gravity waves, right? Because it's not anything that you can detect with any other means. It's not any other kind of ton or photon or electron or thing that we associate with energy. But clearly it is energy. So, what's this story? So it can't be gravity being caused by little clumps of these things breaking off, and all the little clumps have gravity, and so it's this collective amount of gravity from all the little clumps, right? Because we would be able to detect the clumps if they existed. So no clump theory works. So this isn't a dimple in space. This isn't space-time being bent down by gravity. This is a production of space-time. This is the first time, the actual destruction, you could say, of energy, right? One of Einstein's rules, right? Energy or matter, energy can't be created or destroyed. Well, here they're destroying it. They're converting the energy of the three suns into something that's not energy. Gravity isn't technically supposed to be energy. It's supposed to be just a bent field, okay, that magically causes stuff to do stuff. I mean, it sounds like energy, right? Well, that's what I'm saying it is. Of course it's energy. And of course you might as well just make it into a particle and just forget this nonsense. But that's where I'm sort of, this sort of just validates my point, because if it's true, yeah, they've created gravitons. They've converted three suns into the photon without a frequency, the undetectable photon, right? If photons didn't have a frequency and they were just little things moving at random distances from each other, you wouldn't be able to see them with any kind of detector, except matter, because they would make the matter move, like gravity does, and magnetism. So those would be my theory of tonness. So you don't need a space-time, because the fabric, moving stuff, is actually a field of those tons that are always out there, those little quantons. And so converting three suns into quantons, I can say, okay, that can possibly make sense, because you have the matter in a form that isn't normal. That is, it's not going to produce light or other electromagnetic radiation that we know of, because it's in a deformed state. The matter inside a black hole is deformed matter. It's not normal matter in any respect. So the fact that it can't produce something like light could make sense, because it's, you know, like I said, the electrons have been compressed. Maybe the electrons are completely destroyed. I mean, in a black hole, you could argue that maybe there are no electrons, just because they have to compress this matter. And really the only way to compress it is just to get rid of these nuisance electrons and force the proton-neutron combination to somehow balance. But that's it, you know, charge-wise, to make it possible to just smash a bunch of neutrons into each other. And they have these neutron stars, so they're sort of like the precursor to a black hole, I suppose, in that sense. So I guess you could just argue that a neutron star is the fetus of a black hole. Something like that. But anyway, that's if I, you know, like I said, if I just accept this as being good science somehow, and that this all somehow did happen. Like I said, the argument is this is really the creation of a positive lump in space-time. You know, an up lump, not a well created by matter, but an actual conversion of matter into an up lump of what would be called space-time. And that's like a first time ever. So they've detected a new form of space-time, you could argue. And I would argue again that, no, they're detecting gravitons. And my gravitons are different than theirs. Like I said, their gravitons are little balls that are creating gravity. My gravitons are, no, gravity is created by the strength of the little balls, which are basically photons, in the sense that they only have mass in the direction they're moving. That's it. That's the only place they can be influenced, is the place they hit. They can't be hit from the side. They can't be manipulated in any other way. So, like I said, my theory is perfectly compatible with this result, I guess is what I'm arguing, because this is pretty much the conversion of matter into space-time. Now, if somebody has an argument why it isn't, I'd be interested to hear that. But it's pretty much positive gravity. So they've basically changed what was always a pull force. You know, you create the hole and stuff falls into the hole, into a push force, in the sense that now they've converted matter into a positive lump of space-time, a pushing lump. The Earth wasn't pulled towards this black hole event by a gravity wave. It was essentially pushed by it. It was hit, smacked by it. So anyway, but the implications of that are, I mean, any way you look at this, you'd have to say they should be able to find this event in the sense that it should have cleaned out the area. I mean, anything around this thing would be, the force would be incredible. The pushing force, because this is a conversion, unlike like a supernova even. A sun supernovaing is this, pretty spectacular celestial event, but it doesn't happen in a millisecond, and there's a ton of residual bits, matter. The sun doesn't turn all of the mass of the sun into photons or radiation. It just converts a tiny percentage of it into radiation, and it throws out a bunch of heavier bits. A bunch of heavy elements fly out of. That's why we're here, is because the gold and the carbons and all the elements were spewed by those supernovas. So it's a bunch of. It's very chunky, a supernova. This event is converting solar masses into all energy. No evidence that there's any material to this at all, or any regular radiation associated with this. So this is complete conversion into stuff moving the speed of light. Stuff being space-time, whatever you want to call it, but this stuff moves the speed of light, so it is a ton, and there's a ton of it. 3 solar mass, huge concussion wave. So if this stuff, if there was any material body anywhere near this thing, like within 1,000,000 light years, it would have to have been pushed by this event. I don't see any way around the push of it. This is, as I pointed out, you can't really theoretically make any sense out of the idea that there's actually little bits of matter. Like the only way you can make this make sense is that somehow the solar masses are in the form of dark matter, and that it's the dark matter that's moving with the gravity wave or something and creating a dent in space, and that the Earth did in fact move towards the event or something like that. But no. I don't think that makes any sense. So, what can you say? I mean, the people in charge of this thing, they all do look like kind of pseudo-scientists a little. They look a little too showy. It all just sounds a little hypey. It all sounds like we have to justify the $1 billion pissed away on this crap. It just seems for all that money, they feel like, oh yes, well here, we're giving the taxpayers something for their money. Well, you ought to give me something better than this. I mean, you ought to give me pictures of all the little ziggly lines you've got on record. Let me see what kind of ziggly lines you got. Like when a dog barks outside, let me see what that looks like. Let me see what the volcano in Mexico looks like, because you should have a record of all those things. It's a seismograph, for fuck's sake, pretty much. So you should be able to show me what these other shit looks like. And so I'd have some way to know that, oh yeah, this couldn't be anything else. There's no way something couldn't go. And that's all this really is break. That's all it is. So it's just this idea of, I mean, earthquakes do look like this, right? I mean, earthquakes look all jiggly and then they break. They go, and then there's nothing. That's what they do. And it looks like this. And so I just don't get it. It seems a little bit, how do you know? Again, how can you filter for noises we've never heard? It's like filtering for an ice age, when they haven't been through one. Like, they don't have a ziggly line for ice age. So how do they know what ice age looks like? Because they've never seen one. You know what I mean? Can't filter what you don't know exists. So, I just don't. Hard to feel good about it. That's all I'm saying. It just seems like another branch of science where they've just gone way out on this limb. This is like people don't want to hear it, but you can see it with the the gravitational lensing. It's like they're they're wishing it to be true, and they're wishing so hard that they're really just forcing it to exist. And they really don't have anything called really good evidence of it. And it's not where it really should be. And this, like I said, if this is a real thing happening, they're looking at a huge hunk of the universe. I mean, it's a big, it's not, there's no lens on this telescope. And, to say, they know how many of these things are happening, how the hell can they do that? No. It's just way, way overdone. I mean, it's way undercooked. I guess that's all I'm going to say. This is not what science should look like. I don't think. Not the kind of science that just say, we've done it, too. That's just too bold, and, science should have a more cautious temperament. And look, from my perspective, it should have a hugely more, just because I think they've gotten so much. Like I said, there's no bent space. There's energy in the universe, and that energy pushes things together. There's tons. I mean, it's just so obvious. And so, I mean, look, time will I just think the truth is going to be known, and so eventually it's going to be realized that physics got way out of control. I mean, just way, way, way out of control in terms of doing some stupid mathematical crap and saying this is reality because I can do it mathematically, therefore it can be done in reality, and that was a big mistake. And I guess too, I guess it's a liability of complexity. And once you start getting deeper and deeper, you have to start, you don't have the option of having a lot of evidence. Your evidence gets small. It's like the little tiny stuff moving in the like the first microscopes. They probably didn't see things too well, and they just thought maybe this stuff moving around was just particles moving, or this. They didn't realize they're little living things, because they just didn't have the resolving power. So they had to, you draw conclusions based on what you know. And, they're looking so, they have such a pixelated, such a, just isn't really good vision. And so it's a fog they're looking into. But I guess that's where the real scientists should show up and say, okay, it's a fog, guys. Let's not overreact to every little sound we hear. And every little shadow moving. So it could just be a tree waving. We've got to be a little more careful. And I guess that's what's being demonstrated, is there's a real lack of that kind of caution. Everybody's just allowed to go on any kind of wacky tangent, and if the story sounds cool, like Goldilocks or something, oh yeah, that's pretty cool. Isn't it really? I mean, I gotta get the whole thing. You walk around, I don't know, you go to some bear's house and eat porridge. What the fuck was Goldilocks doing anyway? What is she doing out in the first place? Was she molested or something? Run away? What the hell's going on? You gotta go steal some bear porridge? I mean, Does the porridge really take that long to cool off anyway? The bears, they go, let's gotta wait for the porridge to cool off. I don't know if it takes that long. I mean, if whole fucking black holes can crash into each other in a few milliseconds, I think, porridge could cool down in, a minute or two. I mean, it wouldn't just, by the time I got my boots on, I'd be like, yeah, take my boots off, go back to eating. So anyway, do I have anything else to say? Yeah, well, physics videos on the physics channel, so link below to the physics stuff and, my theory of everything paper, and, what else? Yeah, so I do want to do a video on velocity, and, Hathaway made a video on electron spin, and I didn't get much out of it, so I think that whole thing is made out of a different mechanism too. You know, just the probabilities of the whole. You know, look, the whole idea of photons. Like I said, they don't have photons correct, so that's why they don't understand the spin of electrons. Is they don't understand what a photon is, because they don't understand that you can't have. We're not measuring single photons. When they say photon, you already have 2 tons in the photon, but you have to have the frequency. The frequency is the definition of it. And it's already made of a 2 as a minimum, but it could be 3 or 4 or 10. And we just can't tell the difference, okay, between 10 tons of infrared radiation and, you know, 10 tons of ultraviolet radiation. We can't do it. So we see it as an effect, as a byproduct. But you could almost argue that, you know, 4 tons could go into the electron and 2 tons of something else comes out, in the sense that there's only, you know, there's only 2 of them, not 4 of them in a row. You know what I'm saying? So the energy is in the number, not in the frequency per se. The frequency is only relevant in a moment of time, but in an absolute sense, the only thing that matters energy-wise is how many of them went in. Anyway, so I think that has more to do with electron spin, up, down, bullshit. Anyway, so is there anything else physicsy? Yeah. So, but I wanted to make a video. I want to do velocity. So I was thinking more about the, you know, the 3 dimensions are really 6 directions. You know, if you just turn them into approximations, you know, the 3 dimensions are 6 directions. And you know, velocity is sort of obvious in the sense that you go more the way you're going. You collect those arrows, and you give away the ones going in the opposite direction, because you have a bunch of new ones coming in. You know, it's just so obvious. But time dilation only kicks in once you've given away all the this ways you can give away. Then you have to start giving away the ones going this way and the ones going this way, and that's when you start to time dilate. So anyway, yeah, pretty much. Yeah, I don't know whether I have that one fully cooked yet, so I don't know if I'll make a video or not, but I think it's cooked. But you know, I could just find out when I make the video, I guess, and say, oh, you know, well, yeah, that explains it sort of, mostly. Yeah, might need something though. Might need something else. But anyway, that's enough. Yeah. So I think that's it. Yeah, I was just trying to think of the total length of orbits, and you know, as they get stretched out. I have to figure out how much area, you know, the orbit takes. Is that would be sort of relevant to time dilation, as the total area. And so maybe with velocity, it's as the orbit stretches, it also loses or gains area. I'll have to think on that one. Alright, never mind that. That's for another day. Yeah, I'm really working on I'm not really working on it, but I've just been thinking on it, is the electric force. You know, the charge force, that's a good way to put it. You know, just the idea that the parallel between magnetism and electricity and gravity. And it seems to me that electricity just comes down to the fact that it's not, electricity, unlike a magnet, doesn't polarize the field of gravity. It only polarizes, it only reacts to already polarized gravity. It's already charged. And that's why the magnetic force seems stronger than the electrical force, which it certainly is. I mean, charge is just an external, you know, charge is the movement of polarization, where magnetism doesn't need to be moving. Yeah. Anyway, but yeah, that's a whole nother. So anyway, that's I'm working on that, but that's still spinning in the head. So that has to be. I haven't even started drawing that one yet, but we'll get there. There's just so much to play with here. I mean, like I said, everywhere I kind of look in physics, I can see a way to apply this new perspective, and it just answers so many questions. And like I said, that part's kind of fun. But the harassment and ridicule and insults from you assholes, yeah, that's not much fun. But anyway, till next time, and such.